Here's the detail almost no one talks about. Ukraine didn't rely on heavy guns to stop the largest armored push of the year. Instead, the killing began under the ground. 5-inch deep mines wired to hidden control stations and triggered by buried sensors 2 weeks old. Before any missile launched, the battlefield itself had been programmed to detonate with mathematical precision. Before we move on, please take a moment to subscribe to the channel and like the video. The tanks rolled forward in perfect formation, unaware that the soil beneath them held a memory of every vibration they made. Each movement sent faint tremors through the ground, where Ukrainian sensors waited like buried nerves. Those sensors weren't random traps. They were listening devices wired into a silent network stretching across the Kolmus River plain, built precisely for this column. Days before the 13th of September, Ukrainian reconnaissance units had already picked up the signs. Fuel convoys rerouting through Belgorod, encrypted chatter referencing North advance units, and satellite images showing tight armor staging near the old airfield. It wasn't bluff or rumor. Something big was moving west, and every radar trace suggested tanks by the hundreds. When the order came, Ukrainian combat engineers began their work long after midnight. They drove unmarked supply trucks through back roads, loaded with reels of fiber optic cable, explosives sealed in plastic, and crates of unfamiliar instruments labeled only with serial numbers. They worked by muffled headlamps, the light covered by green-tinted tarps to hide reflections from the sky. The farmland near the Kolmus River became their canvas. Freshly plowed fields with soft clay soil, perfect for embedding sensors and wiring. Overhead, French and British control stations kept steady watch, relaying thermal readings and drone sweeps to ensure no movement exposed the operation. From space, the field looked quiet and untouched, just another stretch of rural countryside. The pressure on those crews was immense. They had barely 2 weeks to reshape 7 miles of flat terrain into a remotely controlled trap. A single miscalculation in wiring depth or trigger placement could render the entire system useless. The risk wasn't just mechanical, it was strategic. They were gambling the defense of an entire flank on an untested configuration designed under wartime improvisation. The tempo never slowed. Some teams laid seismic sensors disguised as corrosion rods used for crop irrigation. Others installed decoy metal fragments to mislead opposing radar sweeps. These seismic devices were far more advanced than the standard models. They used dual-phase analysis to read ground motion, able to distinguish the rhythmic hesitation of tracked vehicles from civilian machinery with uncanny accuracy, often pinpointing a tank's location within 10 meters of its true position. Every layer had a task. The seismic sensors detected. The TM62 pressure mines crippled. The M200s, buried deeper and linked to manual triggers, served as the crescendo. This tiered logic made the trap self-sustaining. One triggered sequence fed data to the next, maintaining pacing even amid battlefield vibration. Engineers tested it with careful precision, simulating tank treads using heavy steel plates and small controlled detonations to verify the timing. The field had to act as one connected organism, reactive, consistent, invisible. Inside the command tent, debates grew heated. Colonel Mykolenko wanted full coverage saturation, meaning hundreds of mines across every anticipated entry lane. His deputy worried it could backfire, that early tremors might cause premature detonation. Others argued calibration errors could make the system trigger too late, turning defense into disaster. They recalibrated nightly, cross-checking distance readings by burying empty shells to mimic the reflections of actual armor. Each adjustment came down to centimeters of placement and milliseconds of response time. By dawn on the 12th, the network was fully armed and layered in silence beneath the soil. At 5:38 a.m. the next morning, a faint sequence of pulses reached the underground control post. It was the seismic network coming to life. The monitors glowed green as dozens of readings aligned. Velocity, axle separation, and impact frequency all consistent with heavy armor. Mykolenko leaned over the console, recognizing the pattern before the automated filter even flagged it. The enemy had arrived, and right on schedule. Fiber lines transmitted the data through the buried cable to the steel command bunker, confirming formation entry across all 3 sectors. But that signal didn't call for artillery fire. It armed the real weapon, the synchronized detonation grid that would turn calm farmland into a burning labyrinth before a single gunner had time to react. At 5:47 a.m., the first tank vanished under a surge of dirt and flame before any shell or missile was fired. The blast came from beneath the soil, lifting 30 tons of steel into the air in silence that broke only a second later. Underground, in a command node buried 12 feet below the surface, 3 Ukrainian operators were already at their stations. Their screens showed pulsing seismic signatures, each representing a piece of the armored column now entering the kill zone. The bunker itself was reinforced with concrete and lined with fiber optic lines running several kilometers out toward the fields. Inside, the men had a single objective: decide the exact second to unleash the first sequence of M200 detonations and seal the trap they had spent weeks preparing. The area had been shaped to guide the enemy exactly where planners wanted them. The farmland didn't appear dangerous at a glance. It had been sculpted through subtle geography, angled slopes that forced vehicles to drift left, pre-cut drainage ditches resembling simple irrigation channels, and false openings meant to look like escape routes. These features channeled the advancing tanks into narrow corridors where movement could be predicted within meters. From the perspective of drone footage later reviewed, the pattern of their advance seemed almost rehearsed, as if the terrain itself had been giving orders. The seismic warning at 5:38 a.m. had triggered a waiting period that stretched into minutes. In that silence, the operators watched the density readings build. More tanks crossed the threshold, followed by support vehicles and mobile bridges. The goal was not to stop the first few. It was to catch them all at once. When the last indicator light flashed green, the first operator flipped a guarded switch on his console. The TM-62 pressure mines went first, sending shockwaves that lifted several lead tanks just enough to collapse their treads and block the narrow road ahead. Their explosions threw debris across the convoy's line of sight, halting those behind and forcing the rest to compress inward. Then came the command-detonated M200 mines. These were not random blasts. They were linked through junction boxes feeding into the buried fiber network, allowing detonations to roll outward in deliberate waves rather than erupting simultaneously. Each charge blasted soil from beneath the metal, collapsing the terrain structure and trapping every vehicle that had already entered. The 3 operators coordinated through headsets, calling out telemetry numbers and adjusting the timing by fractions of a second as feedback from the first blasts distorted their sensors. Despite that interference, the cascading pattern stayed intact. One section detonated, then the next, each set off based on live readings returned from nearby sensors. Within 9 minutes, the field was unrecognizable. More than 100 armored vehicles were either disabled, overturned, or buried halfway into newly formed craters. The rest of the column behind them had stopped completely, boxed in by wreckage and terrain collapse. No artillery had been fired, yet the area pulsed with heat strong enough to register across multiple infrared bands. For the operators underground, the readouts confirmed what they had calculated during the construction phase. The mine network had performed flawlessly, and the enemy's vanguard had been neutralized before conventional combat even began. Only after the ground finished its work did the gunners move into position to complete the storm. Precision, not firepower, defined that morning along the Kolnis. Every crater and collapse began weeks earlier through surveying, coding, and calibration. The result proved that control of terrain can outweigh sheer numbers. What looked like farmland turned into an autonomous barrier, guided by software rather than soldiers. Military planners now study that sequence as proof that defense no longer depends only on guns or armor. When sensors, algorithms, and soil combine, the battlefield itself becomes the first defender. Stay with us for our next analysis on how digital terrain networks are rewriting the future of warfare and battlefield design.